Hey guys, we're on the last couple sections, some mini lessons that don't really relate to anything else. So today we're going to talk about solving an absolute value. What shape does an absolute value make? Well, it makes a V. How many times can a line cross an absolute value? Well, it could cross it twice. You could cross it once. Or it could cross it none. So absolute value has two answers, one answer, or no answers. We're always going to find two, but maybe they don't work. Those are extraneous. So how do I do this? Isolate the absolute value. We're going to get the absolute value by itself, and we cannot distribute into an absolute value. Write two problems for possible answers. One is the same with no bars. The second problem, we negate the no bar side, or we put a negative with it, and we separate the two problems with or. Solve each problem, and then check your answers, because like we said, sometimes you get two, sometimes you get one, and sometimes you get no answers that work. So let's try this one. Real easy. The bars are by themselves, so I just split it into two problems. X minus 3 equals 10, or x minus 3 equals negative 10. So that means x equals 13, or x equals negative 7. Let's check it. Is the absolute value of 13 minus 3 equal to 10? Yep. Is the absolute value of negative 7 minus 3 equal to 10? Yep. They both work. That was a really easy one. Let's get a little bit tougher. Isolate the bars. So 2, absolute value of x plus 2 equals 8. Absolute value of x plus 2 equals 4. Split it into two problems. X plus 2 equals 4. X plus 2 equals negative 4. X equals 2. Or x equals negative 6. Check your answers. 2, absolute value of 2 plus 2 minus 3. So that's 4, that's 8, that's 5. That works. 2, absolute value of negative 6 plus 2 minus 3. That's negative 4, positive 4, 8, and that's 5. That one works too. How do we solve or graph an absolute value inequality, less thans or greater thans? Treat an absolute value inequality the same as an equation, except if it's greater than or equal to, we separate with or, just like we did with the equation. If it's less than or equal to, we separate with and. Draw a number line which includes our two solutions. Plot the two answers. If it's equal to, we put solid dots. If it's not, if it's just greater than or less than, we put open circles. Shade the correct direction. If it's and, the correct answer is an overlap, which means there might be no solution. If it's an or problem, the correct answer is the entire shading, which means there's a possible all real numbers. What does all that mean? Let's try it. So, isolate the bars. That's going to be 21. Greater than or equal to. Greater than is or. X plus 5 is greater than or equal to 21. Or x plus 5 is less than or equal to negative 21. I have to flip the bars because I changed the sign. X plus 5 is greater than or equal to 16. I'm sorry, x is greater than or equal to 16. Or x is less than or equal to negative 26. So let's draw our number line. Here's negative 26. Here's 16. So I need to shade solid dot and solid dot. Greater than 16 is this way, or less than negative 26 is this way. And that's my answer. Or problems usually go out. Not always, but usually. How about this? Is this an and or an or? Well, I need to isolate the bars. When you divide by a negative, it flips the sign. So negative t plus 7 is less than or equal to 7. That makes this an and problem. Negative t plus 6 is is less than or equal to 7, and negative t plus 6 is greater than or equal to negative 7. Solve your problem down. Negative t is less than or equal to 1, which means t is greater than or equal to negative 1. I divided by negative 1, I flip the sign. Over here, negative t is greater than or equal to negative 13, which means t is less than or equal to positive 13. Draw my number line. Negative 1 and 13. Solid dots because it's equal to. And means the overlap. Greater than negative 1 and less than 13. The overlap is in the middle. And problems usually shade the middle. Not always, but usually. Let's try this one. Let's get the bars by themselves. So 3, absolute value of x minus 5 is greater than or equal to negative 3. Absolute value of x minus 5 is greater than or equal to negative 1. Greater than is an or problem. X minus 5 is greater than or equal to negative 1. Or x minus 5 is less than or equal to positive 1. X is greater than or equal to 4. Or x is less than or equal to 6. This is an interesting one. Now remember, or means either way. Not the overlap, but the entire thing. Here's 4 and here's 6. If I shade greater than 4, that's everything this way. If I shade everything less than 6, it's that way. So I've shaded everything. So my answer is all real numbers. It's the entire graph. Because or means anything. Not just the overlap, but the entire thing. Let's try this one. 5, absolute value of x plus 2 is less than or equal to negative 10. So x plus 2 is less than or equal to negative 2. Split your problem. X plus 2 is less than or equal to negative 2. And x plus 2 is greater than or equal to positive 2. That says that x is less than or equal to 4. And x is greater than or equal to 0. Wait a minute. Think about that. Here's 4. Here's 0. How can I be... Wait a second. Negative 4. Negative 4. Sorry. So how can I be less than negative 4 and greater than 0? They don't overlap. So this one is no solution. My two graphs wouldn't overlap if I drew them. So that's absolute value equations and inequalities. Remember, check your answers and make sure your graphs make sense. If you have any questions, guys, come talk to me.